with that, I think we're going to turn the time over to our trainer tonight. We're really grateful for Brian Anderson being willing to come and talk to us about grounding our amateur radio stations. And following Brian, we have a couple of folks who are going to show and tell some favorite antennas. But Brian, please go ahead and let's talk about grounding.
Okay. Well, thank you, Holly. Holly called me about 3 weeks ago or something and said, we're doing quarterly training. Would you do a presentation on grounding? And I said, sure, why not? So I thought grounding's pretty simple, right? And so fast forward to yesterday, and I saw a note from Holly. It says, don't forget to come to our quarterly training. And I thought, oh, that's coming up pretty quick, isn't it? When is that? And I looked at it as tomorrow, which is today. So I hurried and got some information together and did a little studying. And I found out it's a lot more complicated than I realized. And we'll get into some of the specifics on that as we go. But I found this presentation on here. There were a lot of presentations that went way deep into a lot of stuff, and I didn't want to get that deep, but this one looked like it was right about the right level. So we'll get started here. And basically, Ohm's law talks about E equals IR, and that's what we know about grounding. And for HF or AC, it's V equals I times Z, which is our impedance. And then we get into this one, which voltage is capacitance divided into the integral of current over time, plus current times resistance, plus inductance times the derivative of current over time. And a little comment there is why they bring that polar coordinate and imaginary numbers information into the extra exam. So that's something, if you haven't got your extra yet, you can look forward to some of that. But we're not going to spend a lot of time on that tonight. Got yourself a power source, and there's no impedance, no current. It's not connected to anything. So we don't have any issues here yet. But now, if we connect up an impedance across our power source, we got voltage and we got current, and we've got a circuit that's functioning. So now if we short circuit the power source, in this case it's a battery, we all know that's not a good idea because current is going to be infinite. There's no way to shut off the power supply for a battery other than to disconnect it. So we've got no impedance and infinite current. And if we go to an open circuit, again, we have no current and no impedance, but we still got voltage on our system. Then we got a capacitance in our circuit. So if it's DC, the capacitor isn't going to allow any current to pass, right? So basically we just have voltage across our capacitor but no current in the system. And then can current jump the gap in a capacitor? What do you think?
Not once it's charged.
Not with a little battery, but yeah.
It depends on the voltage.
Absolutely.
If the voltage is too high for the capacitor's design, it will jump.
Absolutely. It's called the breakdown voltage.
Right.
And that silicon wafer that's inside there, or whatever kind of a insulation material you have, dielectric in there, it can break down depending on the voltage, the higher the voltage. So yes, they have that breakdown voltage. So we can get a current there if we add enough. For example, if we get a lightning strike, is that going to break down your capacitor? By all means.
Among other things.
Okay. Oh, so Now we got, okay, so that's the one we did there. Can electrons jump air gaps? So, absolutely. We all familiar with spark plugs in our vehicles. And that's exactly what that's doing, is it's breaking down it's atomizing the air because you got significantly high voltage, 18, 20, 25,000 volts across there, and generates that spark. So we do have that. And now we get into lightning. The charge that builds up in a thundercloud is going to be one kind of a charge. Let's say it's positive, and an opposing charge will build up on the ground below that. And as the lightning storm, the thunderstorm moves along, that's going to follow. The ground is going to follow. And the difference in potential there between the positive and negative charge is going to, well, it depends on what the cloud's doing. But eventually, if it builds up high enough, it can jump from the cloud down to the ground, and electrons will jump the gap, and you got a big flash of light and a big roll of thunder. Brief, but very high current. So they want to go to ground. We got our radio transceiver. It's going to be at a positive, and it's going to be on the ground there too. So if we have our power supply, we got our impedance. This point in our circuit is going to be some value of voltage relative to the positive. But if the ground is at a different potential, then what we've got is difference of potential there, and we can still have a tendency to want to send the current to ground. And if we bridge that with our body or some other conductor, it's going to allow that current to flow from difference of potential to ground. And that's where, if it's our body, we get electrocuted. If it's some other conductor, then it's just going to flow through the conductor, which may impact our circuit there. So instead, if we put a ground wire between this point in our circuit and our ground, that will tie that together. It's going to protect us from being electrocuted across that voltage, and it will allow, basically provide for a safe condition in our Radio Shack. And so that's one of the fundamentals of what we're trying to do with grounding our station. So, a couple of truths. Grounding is like pregnancy. You're either grounded or you're not grounded. There's no such thing as being partially grounded. Okay, I've never been pregnant. I don't know how that works, but I mean, I don't know how you could get. I don't know how you get partially pregnant. But, so ideally, you have a ground when the ground resistance value is 0, and again, that's ideally. The NEC, National Electric Code, allows for a ground to be up to 25 ohms, the difference in the resistance there. So if it recommends that a ground resistance of 5 ohms or less for sensitive equipment, and I think we all feel like our radios are pretty sensitive, and we want to treat them with respect, and we want to do the best we can to try and keep the station safe and protect that equipment. And lastly, whatever kind of soil we have is going to affect the resistance value of the ground. And sometimes we have better soil in some places than others. Some of the comments that I was studying talked about the proverbial saltwater swamp on top of a hill, which is one of the ideal conditions for building your station. A unlikely that any of us actually live in a place like that, so we just have to make do with what we've got.
Can I ask a question?
Yes.
So it said for sensitive equipment, you want to have 5 ohms or less to ground. How would you go about measuring that?
That's a good question. It's extremely complicated. The equipment required is incredibly expensive, and the NEC provides for using more than one ground rod. If you put in more than one ground rod, separated by at least 8 feet, I believe, then you don't have to measure your system because it's guaranteed to be less than the 25 ohms. Trying to get to the 5, that gets into the measurements that we can't afford to do, and so we just need to try and do the very best we can to ground our system and live with it. Okay.
All right, thanks.
You bet. So basically, that's what I just tried to say here. You drive your ground rod, and then you have your other rods, and meters are really expensive, and that's the default is to follow the NEC. Install your ground rods or ground plates, and like I said, putting in at least 2 ground rods connected together will meet the minimum for the NEC. So if you're putting in a ground rod must be copper or copper-clad aluminum, or actually copper-clad steel is what you will normally find. The larger diameter, the more effective it's going to be, especially around here where you're liable to encounter rocks. So try and get your beefiest ground rod you can. 5/8 diameter. They have a heavy copper plate on the steel rod. At least 8 feet long, drive it in the ground with only 3 inches showing. Don't put it in as angle, try and get it as vertical as you can, because you want to get it as deep as you can, and obviously if you go in at an angle, it's not going to be near as deep when you get to the ground surface there. And then you put on a mechanical clamp and use at least 6 wire gauge or copper wire or braid or larger. Don't solder. Anytime you get a high current, especially if there's a lightning strike nearby, that solder is going to vaporize and you've got no connection at all. You can also use a ground rod horizontally in a deep trench at 30 inches if you can't get it in vertically. Obviously the easiest thing to do is you can hit that with your hammer and get that sledge and drive it down into the ground. You're way better off than trying to dig a 8-foot long trench 30 feet deep, 30 inches deep. You can also use a grounding plate. There's a minimum of 2 feet square, and the way they measure that is 1 foot square plate with 2 surfaces gives you your 2 square feet. So 1 by 1, 1 foot by 1 foot is basically your minimum. The ones I looked at, they're larger than that. They're more like 18 inches. If you're doing iron, it needs to be 1/4 inch thick, 1/16 of an inch thick if you're using copper or aluminum or other kind of materials. You should have a hole in the center or somewhere on the plate to connect your ground straps and your ground wires. The top of the plate must be 5 feet below the surface of the ground. So again, we're doing some pretty serious excavating here. And the more square feet, the larger your plate, obviously, the better contact you're going to have with the ground, the more effective it'll be. So for grounding in our house, and this is where I started to learn some things that I found very interesting. Everybody's power supply to their house will have a ground rod. It's required by the NEC, as I said before, they usually put in the 2. That's connected to the green wire, and then there's a single connection from the neutral, which is white, over to that ground bus, which then goes to the ground wire down to the rod. Okay, so that's a single connection. That's your ground for your AC at your house. And every one of us has that. So that's pretty much what you've got.
Just as a comment on that,
Yeah.
a lot of older houses may not have a ground rod. The code allowed them to hook up to, particularly if they had cast iron pipe, galvanized cast iron pipe coming into the house, they could just ground to that. The code has since been amended to require a ground rod in addition to that.
Right.
And if you don't have anything like that to ground to, then your minimum is 2 ground rods.
Right. That's an excellent point.
One other thing, as far as ground rods are concerned, if you say, okay, if I put in 2 ground rods, everything's hunky-dory, that isn't necessarily the case, because the earth varies in resistance greatly. Even within 50, 100 feet, it can have quite a bit difference in resistance.
Right.
And so that is a minimum. And they will let you get by as far as grounding that for legal purposes with the NEC, but don't figure that necessarily means you've got a good ground just because you put in 2 rods. If you could possibly do it, kind of try to measure somewhat and see if you're getting anything between the rods before you hook them together, and see what resistance you get between in the ground. And I understand about the meter and all that, but you can, with an ohm meter, you can start to tell some things.
Right.
And if you can, the best grounding you can get, the better off you are, no matter what the code requires as a minimum.
Right.
So just keep in mind that 2 may not give you a very good ground, even with 2 rods.
That's true. Yes.
So current construction has to have 2 rods, but the older construction where they put one onto the copper or the galvanized pipe,
They didn't put it, well, they put it on with galvanized. and
In
that
some
was it.
cases, they wouldn't have any ground rods at all.
Depends on the code. Grounding has become more strict over time.
Yes, yes,
Originally, well, if you go back far enough, there wasn't any grounding.
yeah.
At one point, a single ground rod or a single water pipe system ground was adequate. Since then, they've said you need a water pipe ground and a ground rod. I don't think water pipe grounds even satisfy that anymore, and now the minimum is 2 ground rods for AC power.
one of the things that happens when those pipes corrode through and you have to replace that, they put a plastic line in.
Yes, if they put in a section of PVC or PEX or something, then all of a sudden your water pipe ground system has become insulated,
Right. So
and it's not doing its job anymore.
Then you have to add additional grounding
Right.
and bring it up to the current code.
yeah.
But if you do have metal water pipes that are going out and feeding your house, you can tie that into your ground, and like the gentleman here said, that will give you a little bit better, more effective ground system than just the ground rods. So. So bonding. Bonding is grounding. That's what we do. We tie everything together. And so those 2 ground rods that they install for your power supply to your house, those are bonded together with a heavy copper wire. Bonding is tying the equipment together to eliminate or dampen intercomponent electrical interaction. And so what they're showing here is you've got a ground bus here. That's the, it says number 2, gauge solid copper wire or solid strap. And then you've got each of your specific components, your power supply, your speaker, your transceiver, your antenna matching system, and your rotator. All of those have a ground connection to that ground bus. And then this is your system ground here. So you run that ground bus out through the wall of your shack and to another ground rod. Yes,
Now, all those devices don't have a grounding terminal on them. Do you have to drill a hole in the cabinet and put a bolt in there or a screw in there?
if it has a 3-wire plug, then that's a chassis ground, equipment ground.
Does that count then? Does that count going to your house system then?
It will if you tie your shack ground, your system ground, or station ground, back to that AC power system ground.
But most of the radios just have the black and red hot cold wires,
Right.
and there's no grounding on those. Most of the radios that you get don't have, they're not.
No,
Their
no.
power supply's connected to the.
There, if you look carefully, there will be a specific ground lug on the back of every radio that would, that you can, that is
Most of them have it.
recommended to
All the
tie to
new
that.
stuff has it.
In some cases, it may look like just one more case screw, but it'll have that little label or engraving of ground next to it.
Yeah,
You can back that screw out, put a ring terminal on it, put that screw back in, and ground your equipment that way.
okay. And it'll work fine mostly without that. You may never notice a problem. It'll probably work a little better, perhaps, if you ground it. And from a safety perspective, it's definitely a lot safer that way. Okay. How many grounds for our purposes? One. One ground. Now, that does not mean one ground rod. Okay? That means one ground system. And hopefully, you can have your AC power system ground rods. You can have a ground rod for your shack. You can have a ground rod for your tower. If you have like a metal tower with 3 legs, they recommend having a ground rod for each leg and tying those to the tower. And then you tie the AC system ground, the tower ground, the shack ground, you tie them all together.
And
That
the house
is,
ground.
that is one ground. And like we were talking before, if you have a water pipe in your house, you can connect to that, a metal water pipe. And every time you get a different ground rod in the system, it'll improve your overall ground capacity. Any questions on that? It's pretty straightforward, but wanted to make sure that that's. Okay. I'm not sure what's.
Your internet may be slow, may be loading.
Okay. So here is our house. Okay, we've got an HF antenna tied to the chimney over there. We've got a VHF antenna up on the side of our roof. We got the Radio Shack on the 2nd story. And they got a ground table tied to the antenna feed line for your HF. There's a special connector that you can tie in there that will short the cable, the braid on your coax to ground. Same thing over here. You got another component there, a ground connector that you can short that cable to ground.
Can I make a point on that?
Yes.
It's best if those are tied together horizontally too. If you tie them a separate ground rod to that thing like that, and the only way back to the rest of the system is through the braid of the cable coming from your shack to that antenna, that's not a good situation.
Right.
It's better if you have that physically all one ground system, and then the cables can tie onto it.
Right. And what the point that they're trying to show here is that if you can ground your feed line as close to the antenna as possible, you can protect your feed line from excessive energy, overheating, damage from like a lightning strike, possibly. And so that's what they're trying to show here. But you're right, when you have that ground, it's best to connect that together, and I think we'll get to that here. This is an example, Alpha Delta. There's other equipment manufacturers out here, but it's just a feed line connector that has a ground connection. You can connect your ground wire right onto that. So here's the different top view of the same kind of scenario. Here you have your ground rod for the HF antenna with the line coming down. The HF antenna over here with the ground connector and the line coming down. And then they've got this connection.
That's what I was
like you were talking about. Exactly. Okay. How many grounds do we have on our property? One ground. Okay?
One big ground system.
One big ground system. And hopefully you're gonna have this one here tied to your AC ground over there. And then this one's gonna be tied to your shack ground. And somewhere in here, if you have a tower ground, it's all bonded together. Oh, there we go. Here's our tower. Bonded with the ground rod on each leg. We got the shack ground. We got the electrical service ground. And what they're not showing is the two antenna grounds, the feed line grounds. Okay. Another way that you can, this is just showing that you've got these rods 6 feet apart at a minimum and joined by ground wire 1 foot deep, buried under the ground. One other way that you can tie these together is using a connection on the inside of your shack by putting another one of those same connectors, putting a series of these connectors on a metal plate, a copper plate, a steel plate, so that they are all grounded, and the feed lines coming into your shack will all go to the exact same ground, because it's all 4 or 5 antenna systems have one of these mounted together on the same plate.
And,
So
that,
that's
and then that plate has a heavy wire running to your ground rod.
Yes, and that goes inside your shack to the system ground. Okay. Talking about generators. The generator frame can serve a ground. Most of your generators are going to have a 3-prong outlet on there that is already grounded. That's grounded to the frame of the generator, so you're okay with that. You cannot, you don't need to connect your generator to its own ground rod. Especially if you're setting up for field day or whatever, something like that, you don't need its own ground rod. It has the ground, basically the chassis ground is built into that. You can, it's not going to hurt anything, but it's not mandatory. So we have an AC ground, which is where our power comes into the house. And that's going to be a ground rod. We're going to have a station ground, which is going to be for our DC power, our 12 volts, and it will also serve as an RF ground for RF that's in the shack, coming along the outside of the braid of your feed line, for example. You can also protect yourself against lightning with those ground connectors that we put in the feed line. There's also lightning surge suppressors that are built into some of the equipment that we have. I've got some items here that this is an MFJ model. It's designed for 4 when I'm pulled out. But this is an antenna switch. You mount this to another plate, like we were talking about connecting your feed line ground systems. Mount this to the same plate perhaps, so that it's all grounded together. And then when you connect your feed lines onto here, then that serves as the same kind of ground. There is a capsule in here for the system. When you select the center part, that's grounded. The feed line coming in is grounded through the capsule. It's a air gap capsule that sort of acts like a fuse. And if there is a lightning strike, we've got dozens of thousands of volts on your feed line coming in. That gas in the capsule will ionize, and it will act like a fuse, and it will short directly to ground, and it'll protect any of the connecting wires, feed lines that go to your radios or equipment like that. So, and then the last part is the RF ground that we try and do that. So I did a level, I think that's 32. And then there's some references, various different things. The grounding and bonding for the amateur radio, that's a separate book from ARRL, and I looked at that. I think I would like to get one. I haven't seen that, but it sounded like there were several things that I looked at that talked about that, and it sounded like it'd be a great thing to have, a resource for that. Just a few other items that I wanted to show. Here's another antenna switch. You can mount that. It doesn't have the electrical surge, the lightning protection in it, built in like this one. But if you mount this to your plate, your grounding plate, tie that into your grounding bus, which is then heavy strap going down to your ground rod, that'll serve the same purpose of grounding your feed lines as they come in. Here's a couple of heavy crimp connectors that you can put on your wires. These are for 2 gauge wires that you crimp those on, and that'll bolt those onto your plate. There's some different kinds of connectors that you can connect your wires together. You can use something like one of these wires here, heavy duty. This is probably a 2 gauge or something, so that you can crimp that on there, connect that in. You can actually use something like this for a bus bar, ground bar in your station if you wanted to. And these split bolt connectors are used for either connecting wires on there and tying a ground wire to that. For example, just put these two together and connect it on there like that. Strip the insulation off of here, and you put half a dozen of these on here. You can tie one to each. You know, tie one to your radio, tie one to your amplifier, tie one to your tuner and transmatch and so forth. What else? ARRL shows, they've got some pictures. I used one of the most current resources I could find. I've got my handbook for '96. I haven't bought a new one since I got my license. And this is the antenna handbook. I've spent a lot more time in that one. But both of these talk about doing a ground setup in your shack. And what they show is very much like the picture that was in the slides there. You've got a ground bus that goes across here. In fact, it looks like exactly the same picture. They say solid copper strap or number 2 gauge solid wire. And the other picture in the handbook here shows a very similar picture, but with a 1/2-inch copper pipe. So basically you set up a 1/2-inch copper pipe across the back of your shelf where you got all your radios set up, and then you can put some little straps from each of the ground connections and clamp those onto your copper pipe. This is a piece of braid off of a RG8 cable. It's kind of corroded and all, but it would make a great ground connection from your radio to the copper pipe, from your tuner to the copper pipe, your amplifier to the copper pipe.
And it's especially flexible, which can be convenient if you're moving equipment around a little bit to get yourself comfortable and situated.
And this is the kind of thing, if you set up your copper pipe, you can actually just put a hose clamp on here. Make sure you scrape it down to get some of the bare copper, and just put a couple of hose clamps on here and connect that on there. Yes.
One of the things with when you got corroded copper like that, in both cases, the pipe and the strap, have you ever heard of Brasso?
Yep.
Brasso is a good compound for removing that corrosion and getting shiny copper without doing damage to the actual physical wires in the braid.
Great suggestion. Perfect. Yeah, it's silver polish will do the same thing. It's not quite as abrasive as Brasso, but if you have silver polish or Brasso, that would do great to take the tarnish off and get a nice clean connection. I took a copper water pipe system out of my cabin the last summer, and I saved a bunch of pipes. So I've got some 3/4 inch pipe and 1/2 inch pipe that, in fact, I was going to mention, when we built our house, my son and I had just gotten our licenses, and we were really excited to put in a ham shack. And so we had a special room. It's 5 by 8. It's not real big, but we put a 8-foot copper ground rod in the corner by the footing for the concrete before they poured the floor in the area there. So we just drove that down in and left it up enough so that it would be poking up above the concrete when they poured the concrete floor. So that's our station ground, and just outside the room is my telephone pole that serves as my tower for my antennas. I've got a separate ground on that, and then around the corner of the garage, about 25 feet away, is the AC power ground. But one of the things that I realized as I was preparing for this is that none of those three are connected yet. Okay, so
They're kind of casually or incidentally connected, but they perform a lot better if they had a large gauge dedicated connection.
yeah, they're not bonded. So that's if there's one thing that you can do to your system, that would be is bond all of those ground rods together. Yes.
So does bonding, I'm still trying to figure out the 8 feet apart thing. If they're within the 8 feet apart, does that count as them being bonded, or do they need to actually have a copper wire?
No. They do have to be connected. You need to have your heavy gauge copper wire, something like this, for example, or you can get a length of your 2 gauge or 4 gauge or whatever wire. But yeah, you want to run that from that ground rod to this ground rod to this ground rod to that ground rod.
The best thing to do is to run one continuous wire through all your connectors and then tap off of that joint. But the thing that bonds them all together, if possible, make that a one continuous run.
Generally, a ground rod will have what they call an acorn clamp on it. It's made out of bronze.
That's this right here.
Yep.
And
you can run up to a 2 gauge wire through that right next to your ground rod. And if you buy a longer piece of wire, you can run that in through the top of that clamp and then out through the bottom of the clamp, and over to the next ground rod where you clamp it
Keep going.
again.
Yep,
If it's insulated wire, then go ahead and cut off an inch or inch and a half of that insulation right at that spot. If it's bare wire, then you don't even need to bother with that.
so yeah, if this is your ground rod sticking out of the ground, like Scott was saying, just run that through there and then continue it on to the next ground rod. And the screw here will clamp that wire and make sure that you've got a good electrical connection. And that's pretty much all I had. This is a ground bus that you would see in your electric panel. You can buy these separately, but they would work well for trying to ground equipment in your station.
You could put one of those on that copper plate at the back of your work table in your station. Run 12 gauge wire to each of your little pieces of equipment, and then run heavy wire from that out to your ground system.
Yes.
One thing, if you do that, you notice that's silver colored, the copper plate's copper colored. You gotta make sure that this is a metal that is compatible with the copper. If you use one that is not compatible, most of them are.
Yeah,
But-
being that that's
But
an accessory for a breaker panel,
It will be.
I think it will be.
Yeah.
But if you use with dissimilar metals, your grounding system will deteriorate over time because you'll get electrolysis between the two metals, cause corrosion, and make a poor connection. So be careful about
Galvanic
making compatible
corrosion.
metals.
Yes, the bronze that they make the clamps, grounding clamps out of, is a copper alloy, and so that's very compatible with copper.
Mhm.
The water pipe ground clamps that they sell are also generally out of bronze or copper for that reason. They're also a really good way to clamp a heavy ground wire onto a tower leg.
Your tower, because they're designed for pipes that are inch
You can
and
get
a
big sizes
quarter
of
in
them.
diameter.
Oh,
So
yeah.
so they're big, heavy clamps that actually go around a large pipe like that. That's most all I've got here. Open it up to any other questions that anybody might have. Yes.
So at my house, you can't go more than about 4 inches down before you get just rocks like the size of your fist everywhere. It's really hard to get down more than about a foot without hitting some kind of big rock. So trying to pound an 8-foot copper pole into the ground seems like it would be next to impossible.
I got pounders that'll go right through it all.
It will.
Believe
Okay.
me. If you rent one from Lowe's or somewhere and keep pounding, you'll go through all that garbage.
At the metal
One with
pipe.
the two handles and it's.
Yeah.
Yeah, you'll go through it.
Okay.
Yeah, I've got one of those.
Or, Farm Supply, Cal Ranch, they'll have,
Fence pole pounders,
yeah.
same
Yep.
thing, yeah.
Yeah.
You'll go through big rocks like nothing. It's,
The grounding
Really
rod
easy.
isn't going to bend.
The most grounding rods are copper-plated steel,
Oh.
because if they were just
Just
solid
copper.
copper, first they'd be absurdly expensive, and second, they'd be a lot softer and not very strong. So the good grounding rods are a very heavy copper plating on a stout steel core.
Okay. Yeah, I was concerned about both the cost and the strength, so that answers that.
Yeah, the copper-clad steel in 5/8 in an 8-foot length is around $30, which isn't too bad.
Okay.
Go buy the copper wire, the green stuff up there. He's got $300 on the wire right there. That's why in Lowe's and Home Depot has it all locked up in a cage now.
Yeah, yeah.
If I could make a couple of comments, I worked in the telecommunications industry, and I've been to a lot of mountaintop tower sites, and those guys are crazy about grounding. Picked up this piece of wire off the ground on top of North Manan Butte, which is 2-gauge tinned copper, and it's about $6 a foot.
Yeah.
Overkill for just about anything we would need, but it's an awesome product. I'm not sure if it's zinc plated or tin plated, but it doesn't corrode very fast. It's 1/4-inch thick copper. These split bolts, the telecommunication companies use those to tie two ground wires together side by side. If you've got one coming in from the ground, the comm shack, and another that's a ring around the tower leg, then they'll tie them together with a split bolt like that. A lot of sites will have big communication racks, and every single rack will be grounded to a ring of copper wire around the building.
If you were building your, putting your ground around your tower, each one of these connections would be where you'd put in one of those split bolts, you put in one of your acorn nuts on here for that, and you tie those together where you need to.
We built several communication towers between 60 and 120 feet tall, and the installation manual had different grounding requirements depending on which governing body you were trying to satisfy. Some of them would allow a single 10-foot ground rod connected to one leg. Some of them required a 10-foot ground rod on each of three legs, spaced out with the cables running always downhill. The most stringent requirements, which I think were for the European requirements, were three different ground rods with a cable from each leg and a ring tying them all together, much like this illustration. Some of the larger sites I've been to had that sort of a system connected, and then each fence post in the chain link fence and each mast in the cable support frames were all tied to that same grounding, as well as everything inside the building. There was one mountaintop site where things were grounded with 6-inch wide copper strips, solid copper strips. And there were a dozen or more different ground connections coming in from the building here and from 2 or 3 different antennas. And they were low temperature welded onto that strip. There's a lot you can accomplish with grounding. A lot of that can get quite expensive. But if you're on a mountaintop with a tall metal structure, lightning strike is a high risk. And if there's a direct lightning strike, a lot of the things that this large amount of copper can accomplish is more directing the damage than preventing the damage. I've seen a lot of major damage from a direct lightning strike. But it keeps the damage outside, it keeps the damage in certain conductors, it protects a lot of equipment, and prevents fires starting inside structures with good grounding.
Okay. Yes.
One more question. So when it comes to using like lightning arresters versus grounding the braid and shield, is there an advantage to using one over the other, a lightning arrestor or
The lightning arresters with the little gas capsule in them, the braid on the outer conductor on your cable will always be grounded, either casually or intentionally. The little gas capsule functions to connect the center conductor to ground if the voltage rises high enough. It provides a path for the lightning discharge to jump across that capsule, which sometimes destroys it, but they're easily replaceable, and protect the equipment. But at the lower voltages, the transmitter voltages, it acts as an open circuit. So it's just a little shortcut so that lightning goes to ground under those conditions, and you don't have a short circuit on your transmitter when you're transmitting under normal conditions.
Okay, thank you.
Other questions? Nolan?
I've seen, I'm not sure what kind of drill it was, whether it was a LD or something like that, some kind of larger hammer drill. And they drove the rods in with that, just went in slicker than heck.
Yes, they sell a little cup-shaped adapter that'll go on the end of a rotary hammer drill, an SDS-style drill, that will help drive that ground rod in. And usually you can rent those drills from the supply houses. They're not very expensive to rent them for an afternoon or a day.
Or you can get them at regular rental shops, you know.
Oh yeah,
Right.
the A1 rental or
A1,
Pro
yeah.
rental or any of
Right.
those.
Right.
They probably don't have the little cup
You can
for
buy
the end
you
of
have to buy
the
the cup separate. when
for
you
the
do
end of
that.
the ground rod, but they're only like $15. You find them all over Amazon and stuff.
If you've got rocky ground, it might be worth it.
It could be, for sure. Okay, other questions? Just to summarize, put your antenna switches, mount them to a plate, put your coax ground connectors on the same plate, set up your ground bus, connect all of your equipment with short leads to the ground bus. Connect your ground bus with as short a possible lead to your ground stake, and then bond all of your ground into one continuous connected system.
That's all I have in my mind.
All right? Well, thank you very much.
There's not much ground.
I got more done on copper bus.
What comes in on that?
Brian, that was remarkable. Thank you. Are there any other
That's where
questions?
the power comes in. So there's ground there.
Okay. Brian and Scott, thank you so much for this tonight. This has been
Just outside.
thought-provoking, informative, and inspiring. Hopefully, we're all inspired to go home and improve our ground systems.
I know I am, now that I've learned a bit.
That makes me feel better about myself, Brian. Thank you
So
for
the
that.
service from the street.
Okay, we have asked 3 different people tonight to show us some of their favorite antennas.
Yep.
Let's start with Bryce, AI7IQK. You'll hear him on the North Region net frequently, and he's done training on the 9 p.m. Wednesday nets. So you'll probably recognize his voice. Come on up, Bryce.
So this is the cheapest, this is a 2-meter antenna. It's the cheapest fishing rod I could find at Walmart. And this is just primary automotive wire. This piece, I cut it to the length I got out of a book. The 3 radials are just soldered to the braid. And these sticks keep them at about the same angle, and it works. I used an SWR meter to bend a little bit of it. I cut it a little long, and then I just bent it down until it read pretty good. And that's all there is to it.
So 2-meter ground plane, basically.
What's that?
It's a 2-meter ground plane?
It is a 2-meter ground plane, yeah. And with this angle this way instead of horizontally, it's supposed to be closer to a 50 ohm impedance. But I went on an outing with the young men in the ward just before COVID. We went up to Copper Basin, and one of the boys said, bring your radio and your antenna, see what we can do. And I put him on top of a rock, holding this up as high as he could. And I got to the jump-off repeater from Copper Basin, and what was really cool is that Vance Hawley, who runs the jump-off repeater, was the one that answered the call. And so that was really fun.
Did you have him grounded?
What's that?
Did you have him grounded?
No, it was just an HT was all that was on it.
So about how much did that cost you to make, Bryce?
Well,
You go up.
this, the most expensive piece was this. This was, you know, half of a cord that was, I don't know, probably $15. The cheap fishing rod was about $15. And then, I don't know, this is $2 or $3 worth of other stuff, so I don't know, $25.
So do you use that portable? Is that what it is?
I use it portable, yeah. Yeah.
That's impressive. Any
Very cool.
questions for Bryce?
My handy top in the basement.
Awesome. Thank you, Bryce.
How high off the ground do you like to have it toward you?
So sometimes I just tie it with a piece of string to the arm of my camp chair. I've got a little box with a radio in it, but I've got a PVC tube on, and so I just set it in that. You know, up in Copper Basin, the rock was about that high off the ground, and the kid was a tall kid, and he was holding it as high as he could reach.
Awesome. Okay. And that's 7G. Did I get your call sign right?
Yes.
Come on up, Dale. This is Dale Handy. Let's ask Dale to share some things.
There's your roll tool.
Did everybody get a chance to see Brian is going to, and then Brian is going to look back to that road?
So I brought,
Would you like me to put up here?
well, whichever one you got. These are HF antennas that I use. I like these two. Yeah, so there, I like that one. I've had that one for a number of years. It's an Alex loop. It's about 1 meter. I forgot and left it in the car. But
I've used that to make contacts all over the country. Field day a number of years ago, I used my KX3 and that, and I was talking to people all up and down the eastern seaboard.
So what frequencies?
40 meters down through, up through 10 meters. And at 10 meters, it's pretty broad. At 40 meters, man, it's a hair trigger on that capacitor.
So, is this a church house bricks? Like
You
this
know,
one?
that picture I
What's
think
the
was
size?
taken in Brazil
Oh.
by the manufacturer.
So show us with your arms about what size this is.
That's about that wide.
And you're talking to people, is it set on the ground or is this on your,
You should keep it about a meter off the ground.
wow, that's all?
Yeah. And man, you can make, especially when the sunspots are up like this, you can make contacts all over the. I've spoken to people with that antenna in Australia, New Zealand, Japan.
Is it directional?
Yes.
Oh, yes.
Yeah. So it's directional in the plane of the loop.
It's got a great null.
Yeah. So it's null through the axis of the loop.
Pointing out from the screen.
Right.
Yeah.
Okay.
And it really works well. Now that only handles 20 watts. So any more than that, there's a capacitor in that little box, and any more of that will just burn through the capacitor. But they do make them in larger, but the source of the capacitors they use for those is Russia, and it's a little harder to get the capacitors for those right now.
I use one permanently. It's 100-watt capacity
Yeah,
from MFJ.
What was the name of this again?
this is an Alex loop.
And where did did you make it?
I bought it. That was, I can't remember, it was Ham Radio Direct or Gigaparts, one of those two. And I think now you have to get it through DX Engineering. I think because he's not making as many, so he's selling them directly through. So this guy's just from Brazil. And he made contacts all over the world with them. Couple other antennas. These are kissing cousins or brothers or whatever from the same manufacturer. I have an in-fed half wave and a random wire. Man, if I can pull that apart, there we go. It's like opening up a cheese stick. Ain't gonna happen. So this one is my in-fed half wave. So there's a 49-to-1 transformer here and 33 feet of wire. So, and it fits right in the box with my KX2. So this one's tuned for 20 meters. I can throw a extension on it and get it up on 40 meters. But I don't have to do anything to tune this one. Just throw that wire out. I usually either put it up on a mast or put it up on the up in a tree and make contacts all over. So that one's specific 20 meters. I can use it on 10 meters as well. This one is an end-fed random wire, and so that's a 9-to-1 transformer in there. And again, this one I think has 37 feet of wire. So again, you can throw it up. You need a tuner with this, but I can operate 80 meters to 10 meters. If I threw an extension on it, it'd work better on the 80 meter side. But it works pretty good, 40 to 10 meters. Probably would do 6. I haven't tried 6 this year. This is just RG316. The other half of the antenna is your coax. These antennas will handle 100 watts. If you use 100 watts, then you should use a choke bellin with them up near the radio. But for 10 watts, I don't need that. Anyway, so they just fit in my box, my bag, and away I go.
Very cool.
Pardon?
Very cool.
And this guy that makes them, he just moved from California to Portland. I think he's getting out of the fire and into the frying pan.
Don't invite him to Idaho.
No. He does this podcast called Ham Radio Workbench. If you get a chance to listen to it, they talk about you measure the podcast duration in acres of yard you're mowing. They tend to be 2 hours is a short one. I don't know if they've ever done one under. Well, they've probably done one under 2 hours, but typically 2 to 3 hours. But they talk about building and all sorts of things that with constructing things for radio. Anyway,
Thank you, Dale. Any other questions for Dale? Okay, thank you so much.
You betcha.
Let's go next to KF7TGD. Jonathan Dodge has brought some of his, and we've got some photos for him too.
My stuff's not so interesting. It's all store-bought, but brought a couple of go kits with me. So, big into GMRS lately because of setting up a communication net for my ward community. And so they're not using GM, they're going to use FRS and GMRS. So did multiple range tests with handheld GMRS radios, different brands, and I have an unnatural preference for Ocean brand. Anyway, and as part of the range tests that we did, so the area that we're covering, by the way, is 3 miles east to west and 2 miles north to south. Okay, and so and then my house is kind of in the northeastern side of that, and so Cheryl would be listening, and you'll see in a second, I have a big monster GMRS antenna, so I can hear everything. But you can hear that anywhere in that area, all the way down to Blackfoot even, with that antenna. But you can't necessarily, at my house, you can't necessarily hear signals coming in if it's from a cheap little walkie-talkie, right? Because it just don't put out very much. So anyway, with these 5-watt handhelds, during our test we were driving around, and there was one corner where it dips down in elevation a little bit and it would get scratchy, but otherwise it was full quieting all the way around from a handheld back to the house. That was with the stock antenna, and then so I didn't bring the stock antenna, but they're about 8 inches long. So then we put this Nagoya on there, and then it would hit all 4 corners clear. So it did make a difference. I was skeptical at first because I've heard these do nothing, but actually did give me more range than
In general, for the roughly $20 that an aftermarket antenna like that costs, you can see 2 to 3 times the power output, radiated power, compared to those little inexpensive rubber duckies that are included with the radio.
That's good to know.
Yeah.
So, yeah, same thing for the ham. They're tuned though for specific. So this is GMRS specific, so 462 to 467 megahertz. And then I did another test with my friend David Gilmore down in Shelley, and this is just a mag mount antenna for GMRS. I was using a different one. He had a little stubby, thick one. I guess, anyway, I put it on top of the car and drove from his house in Shelley. We lost reception on my on a handheld like this. By the time I hit exit 119 coming in Idaho Falls. So we were, I don't know how many miles away.
That might be 6 or 7 miles.
Yeah, it's more than that.
About 6 miles.
Yeah, is it 6? Anyway, yeah, so pretty good, and actually we picked them up again because at that exit we were kind of dipped down, and then we got back up on Highway 20 and we picked them up again. So it was just really elevation.
terrain makes a big difference.
Oh, yeah.
If you're-
Yeah. So anyway, it didn't, it gets you pretty good range. Maybe not quite as far as I'd hoped, but, and then what I do, my GMRS radio is, pardon me, I just set it up as a go kit. So in my house I have the type N connector on the end. antenna. So I got, this is a picture. I got a second-hand little backpack, which I didn't put it in, but anyway, fits it like a glove. But I've got this frame from, I forgot his name, but anyway, he makes these frames. And then just run a little coax cable to the back, and then a BNC connector. I still have my N-type connector on there, but anyway, adapter. And that goes out to my Comet. This is my favorite antenna. It's the Comet GP6NC for GMRS. So on 5 watts I can talk. It's the taller one there. It's 28 feet up, and it's 10.5 feet tall antenna. And I can hit Rexburg, and I can hit Shelley on 5 watts in the antenna. That's pretty good, I thought. So anyway, let's see. The only other thing I had to show you was, and I haven't even tried it yet, but there's a guy on YouTube that likes these. Personally, I like the Nagoya antenna, so I wouldn't buy it again. But this signal stick. I forgot to work my backpack here. So this, you can fold it up, you know.
Don't transmit like that.
wire, when is
Huh?
it?
Don't transmit like that.
Yeah. I don't know how good this antenna is, but for my hand radio, the dual meter go kit, I got this battery. You know, one of these. Is this a Slim Jim? Is that what that's called? I forgot. It's a ladder antenna from N7TAX or somebody like that. Right? Anyway, J-pole. So it's not, you know, I mean, being a J-pole, it's
Can
works
you open
okay,
it,
but
show it to us a little bit if you can.
you don't get
It's a
the,
ladder line jump off.
you don't get the gain of putting it up, way up in the
Yeah.
air, and, you know.
However, it is probably a decent bit better than a mag mount on top of the vehicle, or especially a rubber ducky antenna,
Yeah,
and far more portable than a 10-foot long antenna on your roof.
yeah, right. And I got this, I think these are for putting up windsocks or whatever, but anyway, it's a
Telescope.
fiber, it just keeps going out and out and out and out.
Is it called a spider pole?
Well, this one says, I bought it from DX Engineering, and I forgot the brand, but it shows up and it says something about windsocks. It says Spirit of Air windsock display.
Yeah, it's a telescoping
Same
mast.
thing.
It holds up a lightweight load, and that's all it needs to do.
It's carbon fiber. Yeah, so it's anyway, I got that to hang this on.
Cool.
For my go kit.
Yeah, if you end up away from your house and you're operating off a folding table next to a building, then you can set up a fairly decent performing little station with those.
Yeah, that's the idea.
Do you want to run through any more of your pictures?
Oh, my slides? Oh, yeah. There's my, oh, you know what? Yeah, what I did for my mast, I was going to show you that. I got those cheap fiberglass things over at the Army Navy surplus, the tent poles. And then, but I was just worried that's just not strong enough, right? Because I wanted to go up 28 feet. So I got a couple of friends who do welding. Went over to one friend of mine. I bought some conduit at the hardware store that just fits inside this fiberglass tube. And anyway, I spent like 2 hours wandering around the aisles, finding stuff that I finally could basically, I had him make a steel tube inside a fiberglass tube, is what we did. And so the two go together, and I have a couple slides of those steel tubes, I think. And
Is that the
I wouldn't want to do this again, because I mean, I put grease on the outside of them, and I had a rubber mallet, and I was banging for all I was worth to get them together, because they don't, you know, it's tight. But I did get them together, and it is pretty strong. It's still standing anyway.
So do they still come apart, or do that make it a fixed?
You can take it apart.
You can still take it apart?
Yeah. They thread together, because it's pipe fittings, they thread together. So that's what I did. I don't know. I wasn't sure it was a good idea, but it worked.
That's how you find out.
Yeah.
Anything else in there that we ought to see?
I think that was everything.
Rails?
I can key the repeater on it. So I tell them I can't hear it. Go away.
It's the rails on the radio.
I know
Oh,
it keys
yeah.
it, because it keys up jump
Okay,
ship. On the floor, it's hard to get over those hills,
Right.
it's Sawtell.
Okay.
That was it.
I think that's
Of course, on
it.
Cross Street, I was.
Big thanks to Bryce and to Dale and to Jonathan for sharing tonight. I think we can talk about antennas all we want, but seeing them and hearing how they work really in real life makes a big difference. Thank you also to Brian and Scott Anderson. Thank you so much for that presentation tonight. And thank you to Justin Wilson. Say hey to Justin in the back. He is videotaping this tonight, and he's going to post it on YouTube. So it will be available for you to view, and we can share that link with people too. So, are there any other concerns, questions, comments, anything we've forgotten to do tonight?
Where is it going to be posted? On like a channel?
It'll be on YouTube, and will you send me the link?
Yeah, I can send you the link and put it in the group me, whatever works.
Okay, yeah, and I can definitely email it to
Yeah,
everybody.
just email it.
All right.
Yeah, I'll send it out, so watch for one of the ERC emails to have the link in it. So awesome to have all of this training available to anybody. I think I already mentioned that digital is going to be the topic for our August training. It's going to kind of be an overview from NSET and TMS. So bring any questions that you might have. If you're brand new, this will be a great place to maybe get a start. But don't wait till then. If you're thinking about jumping in, please don't wait. But it'll also be a place to get some questions answered if you've been working digital modes
Charcoal
for a
and
while
salt,
too. So,
and water. and everything.
anything else for our meeting tonight? Thank you for being here. It's been a great evening. It's always good to meet face to face. And we'll do it again in August. And I hope
This
you
is the
have a
random?
marvelous
Random.
spring sometime, maybe in July.
Well,
maybe-
I think you already missed it if you,
Yeah,
if you didn't realize
We were
it.
probably like Monday and Tuesday, that was it.
That was summer.
Anyway, we'll hope for no snow in August. Bob Reed, the fellow who arranges this building for us, you would recognize Bob. He just hasn't been able to be with us for a while. We were talking about this in February and said, surely by our April meeting, we won't have to deal with the snow and the logistics of getting him to this building. How wrong we were. So we won't make any predictions for August.
Go green.
Thanks again for being here. We're going to call on Norm Coyne and give us your call sign, and then you can pray.
And
KC7JXI.
to like the